Welcome to this tutorial on using ROS2 with MATLAB and Simulink. Here's the learning path we'll be following throughout this tutorial. In this session, we will focus on another core concept of ROS2, the ROS2 parameter. Let's take a closer look at the outline for today's session. We'll begin by understanding what a ROS2 parameter is and its role in a ROS2 system. We'll then explore how to set and get ROS2 parameters in both MATLAB and Simulink. A parameter is a configuration value associated with a node. Parameters are used to configure nodes both at startup and during runtime without changing the code. You can think of parameters as node settings. A node can store parameters as integers, floats, booleans, strings, and lists. In ROS2, each node maintains its own set of parameters, and these parameters are specific to individual nodes. In this example, the control node has 3 parameters. The planning node can retrieve these parameters from the control node. The planning node can also configure the parameters of the control node by setting them accordingly. Next, we will move on to getting and setting parameters in MATLAB. Let's begin with a Hello World example in MATLAB to explore ROS2 parameters. First, we create a ROS2 node with 3 parameters, A, B, and C. Listing the available services, we can see the options for getting, setting, and listing the parameters. On the other hand, we create a ROS2 parameter object associated with the ROS2 node we created. We can examine its properties in detail. By listing all available parameters, we have found A, B, and C in the list. We can use the get command with the parameter object to access the parameter values. Similarly, we can use the set command with the parameter object to modify the parameter values. We can also check if a parameter exists in the parameter object and search specific parameters as needed. Let's move on to another example, the Turtlesim. In this example, we'll use the Turtlesim simulator to explore ROS2 parameters. First, we start the Turtlesim node from the Ubuntu virtual machine. We use the ROS2 param list command to view the available parameters for Turtlesim. You will notice parameters such as background B, background G, and background R, which represent the background colors blue, green, and red components. We use the ROS2 param dump command to retrieve the current values of these parameters, giving insight into the Turtlesim's background color configuration. In MATLAB, we create a ROS2 parameter object associated with the Turtlesim node. We explore the properties of this parameter object, including the available services such as get, set, and list for ROS2 parameters. We retrieve specific parameters such as background R, background G, and background by to access the current background color values. We can also configure the Turtlesim background color by setting new values for the parameters. Observe the changes in real time as we adjust the values. Next, we will move on to getting and setting ROS2 parameters in Simulink. In this Hello World example, we will demonstrate how to get and set a ROS2 parameter in Simulink. In the Simulink model, add a get parameter block. Open the block and configure it by specifying the parameter's name, data type, and initial value. For this example, we'll use the parameter a with an initial value of 0. We will then start running the Simulink model. Observe that the parameter a begins with its configured initial value of 0. We open a MATLAB script to interface with the Simulink ROS2 node parameters. First, we list and select the Simulink ROS2 node. We create a ROS2 parameter object associated with the selected node. We list all available parameters where the parameter a appears in the list. We use the get function to retrieve the current value of the parameter a. We use the set function to modify the value of the parameter a. We can observe that the updated parameter value is reflected in the Simulink model. Let's move on to the last example of this session. In this example, instead of directly using a ROS2 parameter object to get and set the parameters, we will use ROS2 service to mimic the workflow. In the Simulink model, we set up a service server. When a request is received, the ISNU signal triggers the execution of the subsystem in the middle, which updates the signal value of the parameter a. We configure the Receive Service Request block by specifying the name and message type of the service. We start the simulation, initializing the service server to listen for incoming requests. In a MATLAB script, we create a ROS2 node that acts as a service client. Listing all available service, we can find the service we created in Simulink is in the list. We are now ready to create a ROS2 service client. We create the service request message which specify the desired value for a. When the service request has been sent, we can see the value of A is updated in Simulink. I hope you now have a clear understanding of ROS 2 parameter and get and set parameters in both MATLAB and Simulink. Thank you for participating in this session. In the next session, we will explore the logging and visualizing ROS 2 data. By the end of this session, you will have gained a thorough understanding of ROS 2 bag files, logging and visualizing ROS 2 data both online and offline. I look forward to continuing our journey in the next session.